Okay, this video is in section 3.5. It's the first video, functions with vertical or horizontal shifts. So we're going to talk about all of our functions, all those functions that we did in the library of functions. Now we're going to shift them around. So in this video, we're just going to shift them. We're going to keep them the same shape. And in the next video, we'll see what kind of things you add to the equation to stretch them or shrink them, make them fatter or skinnier. So right now, we're just going to shift them. So, so first of all, right here, I have, hope you recognize this. It's the absolute value function from our library of functions. And I've just made this so I can move it around. You see that I keep it exactly the same shape, but I can like move it up. So see that corner, that vertex is what it's called at the corner right here. So right now, instead of being at 0, 0, it's at 0, 2, right? Well, the way we would write that would be, so we still have this absolute value of x, and all we've done is added 2. Okay? It would still be f of x. I didn't leave enough room for that. Okay? In fact, if we just want to add, if we just want to go up and down, all we do is add something onto it. And doesn't that make sense? Because here we are at the absolute value of x. And if I just go and I just add 2 to every single point, it just moves everything up to 2. Okay? Now, if I subtract 1 from every point, it just moves everything down. So that would look like absolute value of x minus 1. All right? So if we want to go up and down, we just add it on to the end. It's kind of like adding it on to the y, right? We have the main function. Here's our main function, right? And all we're doing is adding something on, and that tells us how much it goes up. So this would go up, this would go down because of that negative sign. Okay, so what happens if we want to go back and forth? Well, let's come back to 0. If I want to come back, if I want to move over to the right 2, and have everything just moved over to the right, I'm going to do that by putting it in here with the x. And I don't just add 2, I actually subtract 2. And here's why. Because if I look at this x, what number could I put in for x that would put the answer at 0? Right? Because that's what I have over here is I have it at 0. Right? That's the y value. So, well, 2. If I put in 2, I get 0. Not negative 2, 2. So whenever we have it in, so do you see how this is inside here? It's in with the x. Then it goes the opposite. It's kind of like it's x minus the shift. Okay, so if I had x plus 2, it would be x minus the shift. So it would be x minus negative 2. That means it would end up over here. Okay, so that's really basically it. And we can do them both at the same time. So suppose I have x plus 2 plus 3. And the plus 3 is on the outside, right? That was how we got it to go up and down. So it would be over negative 2, right? Because this is the over one, and it's the opposite. So we go over negative 2, and then we would just go up 3. Okay, so where's my new vertex? Well, my new vertex is the opposite of this, right? Negative 2, that's what the x value is, because that was the shift on the x. And then it's just up 3. The shift on the y, the one that's sticking out there at the end, it's just added on to the function, that just moves it up. So this would be my new vertex. Okay, so I have some functions here for us to try. Okay, so here it is. Hope you can read it. Okay, it's the square root of x minus 2 plus 1. So you should be able to identify the parent function. So we call it a parent function because the parent function is one of our library of functions. And we do things to that. We shift it or move it, we flip it or whatever, and that gives us our new function. So our parent function here is the square root of x, right? And the square root of x starts here at 0, 0, you remember, and comes off to the side. Goes through 1, 1, because square root of 1 is 1. And it goes through 4, 2, because the square root of 4 is 2. So what will this do? Well, inside with the x, under the radical, right, is x minus 2. So that minus 2, it's x minus the shift. So the shift is a positive shift. So it's going, instead of being starting here at 0, 0, it's going to go over 2, right? But then look, here we have plus 1. So that is the shift on the y. So we're going to go over 2 and plus 1. And that is where our new function will start. And there it is. That's what it looks like. Okay? So here we have h of x. What does this function look like? What do you think is the parent function? Well, we have this fraction, this 1 over x, right? That's the parent function, the reciprocal function. And you remember what the reciprocal function looks like, right? It's kind of centered around 0, although it doesn't go through 0, right? And it has these asymptotes, and it approaches them in these two quadrants, right? Down here and up here. Well, let's see where our new center will be. The x is shifted, it's x minus 3, so that's a positive 3 shift. The y is negative 2, so I'm going to go over 3, down 2, and that's going to be kind of like my new origin, right? Now I'm going to have the graph that goes up here and down here. I'm kind of like drawing a new set of axes around this. And that's what it looks like. Ooh, okay, let's try again. There we go. Okay, so see how this, it looks just like the way it would if it were here. Only this now is our new origin. This is my asymptote. I have an asymptote at 3, and I have a horizontal asymptote at negative 2, which is right where this told us to shift. Okay. X plus 4 cubed plus 1. So do you remember what the cubed function looks like? Starts here. It's kind of centered around the center, and it comes up, right? It goes through 1, 1, because 1 cubed is 1, and 2 cubed is 8, so then it gets really steep. And it does the same thing down here, right? So we want to figure out where our new center will be. We're going to go negative 4 here, right? X plus 4 means the shift is negative 4, and plus 1. So we'll go from the center over 1, 2, 3, 4, up 1. That should be my new center of that thing, and it should go up from there, right? So that's what it looks like. Okay, now we can also throw some negatives in and do some flips. So you notice that this is x squared, and we know what the x squared looks like. But this has a negative in front of it. There's my negative, right? So x squared is that parabola. It's like this. So if I just take every single answer from that parabola and make it negative, what's it going to look like? Well, it's going to be flipped down here like this. Okay, so there it is. It's going down. So see, I would have plugged in, when I put 1 and I squared it, I would have gotten 1, but oh, I've got negative, so it goes down instead. I could put the negative on the inside with the x. Okay, so if it's inside with the x, what do you think that means? It doesn't mean that it doesn't exist because it's a negative number, because it means that it means the opposite of x has to be positive. That means x has to be negative, right? In other words, if I plug in 2 for x, then I'm really getting negative 2, so that's not even in the domain. If I plug in negative 2 for x, then I'm getting square root of positive 2. So it flips it over the x-axis. So if we put a negative in front, it flips it over the y-axis. If we put a negative inside with the x, it flips it over the x-axis. Now let's just look at a couple that will kind of go backwards now. So here we have this function. I want to come up with the equation of the function. So first I have to identify the parent function, right? So hopefully you recognize this as the cubed root function. The cubed root function, only instead of being centered at 0, 0, here it is centered right here at -1, 2. So if we were going to write that equation, the cubed root, and I want to shift it to -1, so that would be a +1, and then I want to shift it up, so that would be up 2. Okay, if we want to look at this, now you recognize this as the reciprocal function, right? But the center now, look, is right here. So that doesn't have a horizontal shift. It's just still at 0, but it's up 3. So that would just be the regular thing. I don't have a shift on x, but I would add 3. And finally, we'll look at this one. This is, you should recognize as the square function. So you notice that this square function is moved over -3 and -1. So to get that vertex, we would be going +3 inside, right? And -1. And then how do we get it down here? So it's flipped down. We have a negative there. Okay, here's your quiz question for 3.5a. In the absolute value function, the tip or the corner is called the vertex. I already mentioned that, right? So here's a function. The parent function is an absolute value, right? You should be able to see that from this function. So what I want you to tell me is, where is the vertex? I want you to write your answer as an ordered pair. That means, with parentheses and a comma between the x and the y. Okay. Put that into Canvas in the quiz.